I have already given the definitions of the topic bivariate distributions. Okay. That is, here f of x y gives the probability x equal to x, y equal to y in the discrete case. The marginal distributions are given by f1x and f2y respectively. That is, f1x, let me write, f of xy equal to probability x equal to x, y equal to y simultaneously. Okay, in the discrete case, x equal to x, y equal to y in the discrete case, f1x, the marginal distribution of x, is given by sigma over y, f of xy, and f2y, the marginal distribution of y, is given by sigma over x, f of xy. Okay, so now we shall consider certain problems. Firstly, we cover the discrete case. Okay, that is, the problem is, here we are given f of xy equal to c into x plus y at the points 1, 1, 2, 1, 2, 2, 3, 1 and equal to 0 otherwise. That is, the function takes the form c into x plus y only at those points, that is for the pairs of x and y only, and otherwise it takes the value 0. Firstly, we have to find the constant c, the marginal distributions of x and y, and we are asked whether x and y are independent. So, we consider one by one. Here, I have defined the marginal distributions. Okay. First of all, we want to find the constant c. That is, f of xy is given as equal to c into x plus y at the point c into x plus y at 1, 1, 2, 1, 2, 2 and 3, 1. Okay, only at these pairs, that, and equal to 0 otherwise. That is, for all other pairs, it takes the value 0. It is very important to note the point. This f of xy takes the function c into x plus y at these pairs only. Okay. So that firstly we want to consider. We can consider this in a bivariate probability table. We can write the form, the probability given in the bivariate probability table. Okay, and x and y takes the values. What about x? Let me write x as row and y as column. X as row and y as column. X takes the values 1, 2, 3. X takes the values 1, 2, 3. The second one, that is the these pairs are given by x, y. Okay, so that first value represents x and the second value represents y. So that x takes the values 1, 2, 3 and y takes the values 1, 2. Only 1 and 2, 4, 5. And the function is given by c into x plus y. That is, first one is c into x plus y, 1 plus 1, 2. So this is 2c, 1 plus 2. What about at 1, 1, at 2, 1, at 2, 1. 2, 1 means this is the value 2, 1. This is the pair 2, 1. So 2 plus 1, 3, that is 3z. At 2, 2, 2, 2, that is 2 plus 2, 4z. At 3, 1, 3 plus 1, 4z. And for all other pairs, it takes the value 0. That is 0 here and 0 here. Okay. And we have the property for discrete random variables x and y. For discrete case, what about the property? For discrete random variables x and y. F of xy, the joint PDF. F of xy gives the probability, so that sigma over x, sigma over y, f of xy equal to 1. That gives the total probability equal to 1. So the formula for so in order to find C, we solve the equation sigma over x, sigma over y, f of x, y equal to 1, which implies that 2z plus 0 plus 3z plus 4z plus 4z plus 0 equal to 1. That is 2 plus 3, 5 plus 4, 9 plus 4, 13c equal to 1. Let me write 2z plus 0 plus 3c plus 4z plus 4z plus 0 equal to 1 implies 13c equal to 1 implies c equal to 1 by 13. That is, we have obtained c as equal to 1 by 13. So that this table takes the form 2c means that 2 by 13, 3z means that 3 by 13, 3 by 13, 4c means that 4 by 13, okay, 4 by 13, and again 4c means that 4 by 13. That is the given bivariate table. Now firstly, we want to obtain the marginal distributions of x and y. Here x is taken as the values of x as rows, so that the row total gives the values of f1x, and f1x is given by sigma over y f of xy. That is, the first row total is 2 by 13, second row total is 7 by 13, third row total is 4 by 13. And here the grand total sigma over x f1x means that 2 plus 7 9 plus 4 13 by 13 equal to 1. Okay, here sigma over x f1x equal to 1, which also gives sigma over y f2y. Let us check. That is, y takes the values 1 and 2. So here the column totals gives f2y equal to sigma over x f of xy. Let me write here f1x equal to sigma over y f of xy. That is the marginal distribution of x. So that we have to sum the probabilities of y, that is sigma over y f of xy. For x equal to 1, it is equal to 2 by 13 and so on. And the marginal distribution of y is f2y. So we have to sum up the x values, that is sigma over x f of xy gives f2y, that is here column totals. So 2 plus 3, 5 plus 4, 9 by 13 and 4 by 13, and the grand total or sigma over y f2y equal to 9 plus 4 13 by 13 equal to 1. Okay, that is, we have obtained the marginal distributions of x and y. Let me write marginal distribution of x as x, the values of x are 1, 2, 3 and f1x equal to 2 by 13, 7 by 13 and 4 by 13. Similarly, marginal distribution of y is y takes the values 1 and 2 and f2y equal to 9 by 13 and 4 by 13. Okay, so first part is over. Now we want to obtain the conditional distribution of x and y. The conditional distribution of x and y, f of x given y equal to 3 is to be obtained. The second part is f of x given y equal to 3. F of the question is marginal distributions of x and y, and we want to consider are x and y independent. I'm sorry. Next question is the conditional distribution. Okay. So that here we have to obtain are x and y independent. That is, x and y are independent The variables x and y are independent if and only if of x, y equal to f1x into f2y for all x, y. Okay, let us check. What about f1 of 1 into f2 of 1? That is the first row total into the first column total, 2 by 13 into 9 by 13. It is not equal to f of 1, 1. Okay, here the value is 2 by 13, but f1 of 1 into f2 of 1 is 2 by 13 into 9 by 13. That is, we have obtained that. That is, for one pair it is not okay. That is, for all pairs it will be not okay. Okay, that is, x and y are not independent. Let me write. That is, f of x, y not equal to, or f1x into f2y not equal to f of x, y for all x, y. That is, x and y are not independent. X and y are not independent. Okay. So here we have obtained the value of the constant C using the bivariate distribution simply by solving sigma over x, sigma over y, f of x, y equal to 1 for the discrete case. Now we have the marginal distributions. f1x equal to sigma over y, f of x, y, f2y equal to sigma over x, f of x, y, and x and y, the variables will be independent if and only if f of x, y equal to, or f1x into f2y equal to f of x, y for all x, y. Here the condition is not okay, that is, the variables are not independent. Now we move on to the second problem. Here also we are given the probability in the table. Okay, the probability in the table. The joint PDF of x and y is given below. X takes the values 1, 2, 3 and y takes the values 1, 2, 3. Here there is a difference. The difference is x is given in columns and y is given in rows. Okay, we have to obtain the marginal distributions of x and y. The conditional distribution f of x given y equal to 3 and f of y given x equal to 2. Now probability x greater than or equal to 2 and the conditional probability x greater than or equal to 2 given y greater than or equal to 1. Okay, let us do one by one. That is, we are I am not writing the table. Sorry, we have to write the table. That is, we are given y in the form of whatever, y in row and x in column. Okay, so that x takes the value 1, 2, 3, y takes also 1, 2, 3. And we are given 0.1, 0.2, 0.1, 0.15, 0.1, 0.18. Yes, it's okay. And 0.02, 0.05, 0.1. So that we can obtain the marginal distributions of x and y. Here, as y is given in rows, that is, here f2y, it is equal to, we have f1x equal to sigma over y, f of x, y, and f2y equal to sigma over x, f of x, y. That is, the row totals gives the values of f2y. That is 0.1 plus 0.2 plus 0.1. It is 1 plus 1, 2 plus 2, 4, 0.4. 0.15 plus 0.1, 0.25 plus 0.18. It is 0.43. Okay, it is 0.17. It is 0.43, 0.17. Yes. And the grand total, it is 4 plus 4, 8 plus 2. That is, it is equal to 1. Here the column totals gives f1x. I have written the formula f1x equal to sigma over y f of x y. That is, for the first column x takes the value 1 and y changes, so that f1x is first column total. For x equal to 1, that is it is 0. What about 27? Okay, 0.27, and here it is 0.35, and here it is 0.38. 0.27, 0.35, 0.38. Yes, the answer is 1. Yes, the answer is 1. Okay, that is sigma over x f1x equal to 1, sigma over y f2y equal to 1, or sigma over x, sigma over y f of x y equal to 1. Okay, now we have to obtain the second part. The marginal distributions already obtained. That is, let us write marginal distribution of x. First part. It can be written as a table giving x takes values 1, 2, 3 and f1x. What about f1x? f1x as column total 0.27, 0.35, 0.38. f1x is obtained by sigma over y f of x y. Whether it is in rows or in columns, it doesn't matter. The formula is fixed. Okay, that is f1x equal to, we have to sum up y, sigma over y f of x y, and f2y equal to sigma over x f of x y. So that marginal distribution of y is, y takes the values 1, 2, 3, and the row totals are the f2y values. It is 0.4, 0.43 and 0.17. The grand total equal to 1. That is, the first part is over. Now the second part is, we have to obtain f of x given y equal to 3. F of x given y equal to 3 can be obtained by f of x comma y equal to 3 divided by f2 of y equal to 3. That is, fix y equal to 3. What about y equal to 3? Y equal to 3 is the third row. So we have to divide these values, the third row probabilities divided by the third row total. That is equal to, let me write it as f of x comma y equal to 3 by f2 of y equal to 3. I am not writing the values. Okay, it is simply 0.02 divided by 0.17 for, what about for x equal to 1? Okay, and we have to obtain these ratios for all the values of x. Okay, and for x equal to y, it is 0.05 divided by 0.17. You have to take these ratio values. Okay, for x equal to 2, that is, and the next is for x equal to 3, it is equal to 0.1 by 0.17. Let me once again discuss this f of x given y equal to 3. It is defined as f of x comma y equal to 3 divided by f2 of y equal to 3. That is, we have to fix y equal to 3. Here, as y is given in rows, y equal to 3 is the third row, and we have to obtain the ratios, the third row values at x equal to 1, x equal to 2, x equal to 3. All these values are divided by the third row total 0.17, which is f2 of y equal to 3, the marginal distribution of y at y equal to 3. I hope you follow me. Okay, now we consider the other part. F of y given x equal to 2. What is the formula? F of y given x equal to 2 can be written as f of x equal to 2 comma y divided by f1 of x equal to 2, isn't it? We are usually we are practicing f of x y. So I have written f of x equal to 2 comma y divided by f1 of x equal to 2. That is, we have to fix x equal to 2, which is the second column. Okay. So here the second column values are to be divided by its total, the marginal value, which is 0.35. That is, this is obtained for all y. These values, the ratios are obtained for all y. That is 0.2 divided by the total 0.35 for y equal to 1. Okay, I am fixing x equal to 2, which is the second column. And 0.1 divided by 0.35 for y equal to 2. And 0.05 divided by 0.35 for y equal to 3. That is, we have obtained f of y given x equal to 2 for all y. Okay, f of y given x equal to 2 for all y. Simply the formula is f of x equal to 2 comma y divided by f1 of x equal to 2. So at y equal to 1, the value is, that is second column we have to consider, and at y equal to 1 it is 0.2. So the ratio is 0.2 divided by 0.35. Okay, and for y equal to 2 it is 0.1 divided by 0.35, 0.1 by 0.35, and for y equal to 3 it is 0.05 divided by 0.35. You have to obtain these values and the total will be equal to 1. So here we have obtained the conditional, the two conditional distributions. Similarly, we can obtain f of x given y equal to 1, so that y equal to 1 is to be fixed and so on. If we have to obtain f of x given y, that is, you have to take this for all the values of y. That is, we have to obtain f of x given y equal to what? F of x given y equal to 2 and f of x given y equal to 3 and so on. Okay. So that the conditional distributions is defined, and the last part is probability x greater than or equal to 2. What is about probability x greater than or equal to 2? This is the bivariate probability table, so that we are given this in the table form f of x y. Now probability x greater than or equal to 2 means that probability x equal to 2 plus probability x equal to 3. Probability x equal to 2 means that this column total is probability x equal to 2. That is, we have summed up the values of y and we have obtained probability x equal to 2, which is f1 of, that is equal to f1 of x equal to 2 plus f1 of x equal to 3. So it is simply equal to 0.35 plus 0.38. It is equal to 0.73. Okay, 0.73 is probability x greater than or equal to 2. Now we have to obtain the conditional distribution probability x greater than or equal to 2 given y greater than or equal to 1. What about the conditional distribution probability x greater than or equal to 2 given y greater than or equal to 1? That is equal to, it is defined as probability x greater than or equal to 2 comma y greater than or equal to 1, okay, divided by probability y greater than or equal to 1. What is about probability y greater than or equal to 1? It is equal to probability y equal to 1 plus probability y equal to 2 plus probability y equal to 3. That is, it is the as y takes values 1, 2 and 3. Probability y greater than or equal to 1 is sigma over x sigma over y f of x y, which is equal to 1. Okay, so that now probability, that is, we have obtained the probability y greater than or equal to 1. Therefore, probability x greater than or equal to 2, y greater than or equal to 1 by probability y greater than or equal to 1. Okay, it is simply probability x greater than or equal to 2 by probability y greater than or equal to 1. What is the reason? Y greater than or equal to 1 means that y equal to 1, 2 and 3. So that second column total plus third column total gives probability x greater than or equal to 2. Already we have obtained it as equal to 0.73 divided by 1. So equal to 0.73. So in these problems I have discussed the marginal distributions of x and y, the conditional distributions to find the constancy and to check whether x and y are independent. Okay, thank you.